In this video, we're going to talk about the Quartz GPU power analysis fixture. This is a device which is used for measuring power analysis on a GPU. GPUs are well known for use in gaming PCs and AI applications, and in the news right now we're hearing a lot of stories about the high power usage of AI in data centers, and so it's very important that we can effectively and accurately measure the power consumption of the GPU. There are some challenges in doing this because the GPU runs at a very high speed. It plugs into a motherboard, so we can't get probes and wires in there. There are 3 power rails on the bottom, and there's a further power rail on the top, which run at a very high current consumption. And so we need a very specific and specialized tool to get the best results. So we're going to take our GPU and we're going to plug our power analysis fixture onto the bottom. That allows us to pass through all the high-speed signals. It also allows us to measure 12 volts, 3.3 volts, and 3.3 volt aux coming through the slot. So we also have to plug in our 12 volt auxiliary power, which is this cable on the top. So we simply plug that into our shunt board on the device side. Note the arrow. And now we're ready to put it into the host PC. I'll put it into the same slot it would have gone into before. And we hook up our auxiliary power here. Plug it into our Quartz power analysis module, and we're ready to go. So we've put our GPU into our host PC with the fixture in place, and now we've hooked that up to a laptop on USB, and we've run the Quartz Power Studio software. And what we can do is we can start streaming straight away, and this software will allow us to see all the channels, and I can start up the PC. We can see we're capturing a power up on the software. What this is showing is it's showing us the voltages, it's showing us the inrush current, it's showing us the ramping rates, and it's also showing us a whole bunch of sidebands on there. So for debug purposes, it's very useful to see the assertion of reset signals and that the reference clock is present. Now that we're running, we can easily see in our trace statistics. So I can see my voltages, I can see my currents, I can see the state of the sideband signals, and I can also see the power consumption of this unit. Currently 8 watts. A modern GPU can go up to 600 watts continuous, and it can go up to 1800 watts for a short period of time. That is a huge dynamic range, and something that the Quartz tool can deal with very effectively. We can record for a long period of time, almost indefinitely, and we can very easily export that data to other software packages and scripts for automation purposes and for analysis, comprehensive analysis. So we've got our system up and running now, and what I've got is an AI image generator. We can see on our screen here that we're running at about 3 watts at the moment, and we can start an AI image, and I can see in my timeline down the bottom here that our power consumption has gone up significantly. We're now pulling 60 watts for a short period of time to generate one image. This is one GPU in one system. In a modern data center, we have multiple GPUs in a rack, and we have multiple racks in the data center. Not only does it cost us energy to power those, it costs us energy to cool. And that's a huge problem for modern data center providers, is the fact they have to spec very, very expensive power distribution and cooling architectures. And if they underspec it, they have a problem. And if they overspec it, they have a problem. So what our tools allow our customers to do is to very accurately assess the power needs for their application, which is crucial.